Hello everyone. Today I'm going to be talking about ordinary regression missing values. My name is Lido Tangachan. So, what do we do when we have a lot of missing data in our data sets? That is what I'm going to be discussing. The solution for this problem can we have three solutions for this problem. One would be dropping the entire case. Second would be replacing missing with mode or average. Third would be replacing the missing values with multiple imputations. In dropping off entire case, what we do is we remove the complete rows of data that has the missing values. Let's say a patient has a lot of missing values in their demographic details or any lab results that are necessary for our analysis. We drop that patient. It seems good, but it has a lot of issues with it, such as loss of as valuable information, reduced sample size, potential bias. So, one thing to note down is if you are going with this method, make sure you note down each and every step of your analysis, what you're removing and why you're removing that row or column, because that can lead, if you note down everything, that can lead to no reproducibility of the results. Second is replacing the missing value with mode or average. If you have binary set, if your data set is binary, then replacing the missing values with mode makes the perfect sense because it is the most repeated value. Whereas if you have a continuous information, replacing it with the mean or median is much more advisable. Third and uh, most robust method used could be multiple imputations. So in replacing missing values with multiple imputations, what do we do is we create multiple data sets, analyze each one separately, and then combine the results. This deals with uncertainty of not knowing the true value for the missing data. Basically, what we do is we take the original dataset with missing values and create multiple copies of it. For each copy, we fill the missing values with possible range of, with the possible ranges of values. For example, if you are having the possible ranges 1, 2, 3, 4, and 5, we create 5 datasets with missing values, and in each dataset we add either 1 or 2 or 3 or 4 or 5 and so on. And after filling up with the missing values in random, we run regression analysis through each of these datasets separately. This gives multiple estimates of the regression coefficients. After that, we average these estimates from each imputed dataset to get the final regression coefficient. Then we calculate the errors. And finally, we get what is a proper missing value in each of these datasets. In R, this can be done by making use of the library mice. So, after knowing this, now I'm going to be explaining the second question of our assignment, where it is divided into two portions. The first portion asks us to create a binary variable that is 1 every time a variable is missing and 0 otherwise. And also it asks us to predict progression in infectious and parasitic body system from the binary database and report if any variable is statistically significant and list variables that are not missing in random. So to solve our second question, first we load the necessary libraries and load the dataset. We are going to be using dplyr, mice, and tidyverse. dplyr and tidyverse to manipulate the data, and mice to do multiple imputations. After that, we are going to drop the first column, that is the ID column, from our database. Then, since it asks us only to use 10% of the data, we are going to reduce the sample size to 10%, and then we are going to fit it in random. Once that is done, now we are going to convert deal with the missing values by converting it by creating a binary indicator. For that, what we are going to be doing here is we are going to be creating a loop where if there is a missing value, it's going to be replaced with 1, and if there is no missing value, it's going to be replaced with 0. After that, a regression model is created using GLM function, and in this regression model, we are going to be taking BS1LR as the dependent variable and rest as independent variable. And once the model is done, we are going to be summarizing the model. So this is how our answer will look like. As you can see here, after after loading of database and entering the variables, this is how our data looks like. The ones represents the missing values and the zero represents the values that are present in the data set. Now as we go down, we can see all the missing values and the variables that are present in the dataset. Once the model is built and the function is called, we can see these are all the significant ones. As each star indicates the significance, we can see the standard error, the z value, and p value. Each star shows the significance code. If the p value is 0, it is represented by 3 stars, and if the p value is 0.001, it is represented by 2 stars, and if there is the data is not significant, it does not have any stars. As we can see, BSL15LR and BS7LR are the two data that are showing missing variables that are not missing at random. This completes the first part of the question. As we see, we have created a data set with ones and zeros, and we find which are the significant ones and which variables are not missing at random. Now, coming to the second part of question, where we have to do multiple imputations. What we do is we create the variables that are to be imputed, and we select the number of times it's going to get imputed. In this case, it's 5. Then we use the mice library and select the number of imputations and the method used for imputations, which is PMM. PMM stands for predictive mean matching for imputations. What, what PPM does is it identifies set of observations that are having complete data and which are similar to the observations that are having missing data. Then it takes the mean of this complete observation and fill in the missing data with the mean of the complete observation. That is what PMM does. Other than PMM, we can use other methods too, such as KNN, that is K nearest neighbors, or Bayesian's imputations. It all depends upon which type of data you are dealing with and what are your requirements. So, after imputations are done, what we do is we take a single column and check if the imputation is done properly or not. Once we see that it has been done properly, we create an empty list where this imputation loops over to rest of the data set, and then we pull the results and we see the summary of the results, and this is how our results are going to look like. As we can see, let me just get up here. Okay, these are the number of imputations that has been done, 5, and these are the columns that imputations has been done for. As you can see, imputation number 1, 2, 3, 4, 5, and for all the columns. So number of events occurred is 86, and now we can see the previous one where it was zeros and 1 showing the missing value and 0 showing the complete value, where we see what is missing and what is not. We go down and we see for just one data set, for one column, that is BS2LR. As we can see, the previous missing data has been filled with imputed data, and there are no more missing data in this column. And once the loop is done and we find the summary, we can see that there is the minimum, first quartile, median, mean, third quartile, and max for every column present here. And this is the end of the presentation, and these are the answer for your assignment. Thank you for your time. I hope I helped you guys.